your PSA?
Smash that like button. Payne-Elliott.
L-Elliott math.
Make sure to
Like
hit that
L-Elliott math.
It's like,
Yeah.
I like calculus.
Sorry for those just joining in. My class is a little bit thing. Okay, can you guys copy down a basic sketch of this graph? Because what I'm going to say with this, the first thing whenever you're given a graph is you have to determine if the graph you're given is f or f prime. You're not typically going to be given a graph of f double prime, although I'm not going to say that that's not possible. But let's say that that is y equals f of x. And that notation is commonly used to say that I'm graphing on a y-axis, and this is a function. So f of x does not need to be confined to a graph, although we typically do graph it. Y equals is where you see something with a graph. I'm not necessarily going to put axes down, although I could. What I'm more concerned about is just kind of the general shape at the moment, and that we identify different pieces of this shape. So underneath this, sort of vertically lined up, if I can do this pretty well, I'm going to try to draw a shape of what the derivative would look like. And that's going to require a few points and a few analysis of where is this graph increasing, decreasing, concave up, concave down. I can do that in highlights. You guys can't, but you can do kind of other little notations. What you're at least going to mark are possible places where you have maxes and mins and endpoints. That's why we look at things like absolute max, absolute min, local max, local min. And then you're going to kind of hypothesize where you see any points of inflection. I know it's a guesswork right now because you're just looking at a graph. But where would you see them? Yes, you're just pointing, from my perspective, just at the board. It's cool. Alex, I kind of know, but yes, right here. We'll just play like, that's exactly where you were looking at. So this is a point of inflection. And you could theorize that maybe there's going to be one over here, but I didn't really make that clear, so we'll leave it without. Graph is increasing from here to here, and from here to here, and it's decreasing from here to here. So an increasing graph should be positive. So if I draw an axis here, and I now call this the x-axis, and I say that we're going to draw a graph of f prime of x. And if I sort of dot these down, a min or max is both going to become a 0, correct?
Yep.
Okay. An additional thing to check is that if I look here, the graph is concave up. And concave up means that that's concave down, not up. It means that f prime of x is decreasing. So I need to draw a decreasing graph wherever this thing is concave down. So since it's decreasing, and then right here, I need one more highlight color. But I want a soft color. Let's do purple. Sorry if you're colorblind.
Do we have any in the classroom for
Not this, but general. Okay, this right here, this section is concave up, and that means f prime is increasing. And because at the point of inflection, f prime goes from decreasing to increasing, what would the point of inflection look like on a first derivative? A what? A minimum. So if you kind of treat how this is going to happen, I'm just going to sort of start in this arbitrary little space up here. We're going to go down, 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 down. This is where it crosses and becomes negative. And then at this point of inflection right here, we should hit a minimum. And then we're going to swing back up, cross over. And I don't really have much telling me that this is going to start changing, so this could kind of continue up like that. And that would be fine. if I sort of started to change this graph right here and make this go like a little bit like this. Oops, no, not like that, sorry. Let's say instead of going a max or min, let's say I change this and kind of started having it go like this. And I say that this is a point of inflection. How would that affect the derivative right here? Yeah. So this would have to change to become a max if I wanted that to match. So if I change it to be a point of inflection on f prime, that would be a max. And this right here would be a min on f prime. And I want to be clear that what I've actually drawn are two graphs. The first graph, I'm not terribly concerned about where the x-axis is, but the second graph, I'm concerned about it, and I want to kind of see because I need to know where it crosses an x-axis in the second graph. And that matches what kind of happens with the first derivative. I mean, in an original function, you don't care what the constant is. Like, if it's f prime of x plus any constant value and you take a derivative, you lose that constant value. So vertical shifts don't matter with the original function when looking at the derivative. Okay, my next thing I'm going to do is I'm going to label these points. So let's say that this right here is point A, B, C, D, and E. The question I want to ask is, where is f increasing? And we're going to do a few of these. So given the points that I put, A, B, C, and D, can you tell me the intervals where f is increasing? And we're going to go with, I'm going to do a little bit of erasing on some of this, so I can kind of eliminate that second little piece I did. We're going to go with this being a point of inflection. So I want it to kind of do this thing. I think I drew that, yeah. I just need to erase this little piece here. And we're going to erase this right here and make that become how the curve looks. Okay, so where is f increasing? Yeah, so we can say it is increasing on A to B and on D to E. Then I'm going to ask, what is f prime doing on these intervals? So f is increasing. What is f prime doing on these intervals? It's positive. We would say that f prime is, so the way to say positive mathematically is just to say f prime greater than 0. Or f prime of x is greater than 0. You're never really going to use the words like it's positive or negative in a written explanation. You're going to use a lot of greater than 0, less than 0. Do you guys know how to say greater than or equal to 0? What the word is for that? It's the word for greater than or equal to anything. So greater than 0 is positive. Greater than or equal to 0 is... No. Greater than or equal to 0. It's like positive and 0. I'm looking for the word that means positive and 0.
Non-negative.
Yes, non-negative. And that negative in 0 would be non-positive. Non-positive can be a single word. So non-negative, non-positive is a thing. Where is f prime negative? Yeah, that would be on B to D. That's the section right here. Oops. Delete. Go back to stroke eraser. Let's delete that. That's the section where f prime dips below the x-axis. Could you have seen that from the original graph without looking at the derivative? Remember, f prime is negative wherever, and the question I'm going to ask is, what is f doing on B to D? And that is decreasing. F prime is negative anywhere that F is decreasing. Let's slide some more questions over here on the left so I can keep this image in view. Where is F prime increasing?
Wherever F double prime is positive.
Yeah, remember this is curving down like that, so C to E. That would be C to E.
CTE?
Yeah.
I remember. I'm never going to forget that talk. Yeah, I'll have CPE. I would do it all again.
What is F's behavior? I shouldn't put F's because that apostrophe is going to look like a prime. So what is F behavior on the interval? When F prime is increasing, F is concave up. And that's what you should see. I know F prime is increasing on C to E, and that's where F is concave up. Okay, you guys have the graph right there. I'm going to throw some more questions down. Where is F concave down? What are the intervals where F is concave down? A to C and yeah, E to whatever. I'm going to put that because without an indication of where that graph is, we don't know, but you get the idea. F is concave down in those intervals. Eight is, what is the behavior of F prime on those intervals? Zach? That is increasing. This is really tricky to think about. F prime is increasing means that F is concave down, means that F double prime is positive. But that's the relationship that we charted out the other day, and that's the one you really have to think about. Last two questions. Where does F have a local max?
Isn't
Wait,
it
isn't it
decreasing?
decreasing?
Yeah, that's what
Oh, it is
That's,
decreasing. You did. I messed that up.
I kind of mumbled.
It's okay. I have earphones on, so I can't hear.
Yeah.
That's not true at all, but, you know. It's true that I have earphones on, so it's true that I can't hear. Where does F have a local max? Just B, right?
B for boy.
And at that point, F prime is equal to what? 0. There's going to be a lot of graphs like this that are given to you. You don't have to draw a lot of them, but you should be able to, where you have to answer these questions and interpret. The single most common mistake, and this is an unfortunate one that happens, is when you look at a graph of F prime and you answer everything as if it were a graph of F. And that would be easy. That would be an algebra 2 question. Like, where is this graph increasing? And you're looking at just a graph. The calculus part is to look at a graph of F prime and know where F prime was increased, or F was increasing, or where F double prime is increasing. You almost always are going to be given a graph of F prime, because from F prime you can answer questions about both F and F double prime. Sometimes you're going to be given a graph of F, and you have to answer a question about F double prime and all that. But just interpreting what's happening is important. Okay, that's kind of all I want to show right now. I'm going to stop here and give you guys time to start homework and just sort of work on this on your own.